In this video, we're going to study the behavior of a JK flip-flop. Here on the screen on the left is a JK flip-flop. I have labels and switches connected to all the inputs to explain its behavior. On the top, I have the list of the way that the flip-flop is supposed to behave. And on the right, I have the timing diagram of what happens as we're going to click the switches. Let me begin by pressing start the simulation, and you'll see that at the moment, my switches are set to 1, 1 on the flip-flop, and my clock is set to 0. My overrides, for the moment, I'm not going to activate them. As you can see, they're both set to 0. So let's ignore the overrides for the moment, and let's see how the J and K behavior affects the output Q. Let's start with setting the J to 1 and K to 0. As you can see, the K became low, but the output Q was not affected whatsoever. In fact, changing J and changing K do not affect the behavior of the flip-flop output at all until the clock is triggered. So I can be changing the input of J and K. As you can see here, they're now both to 0, 0. And here on the graph, you can see this is just a record of when I clicked on and off to J and K. Let me leave for now J to a 1 and K to a 0. So what's going to happen is, as it says on the table, the behavior of a JK flip-flop. When J is a 1 and K is a 0, the output is going to set to 1, but only when the clock is triggered. And what do I mean by the clock is triggered? The clock needs a transition that goes from 0 to 1 in this case, and not when it's a 1, not when it's a 0, but the moment it transitions, almost like pressing the trigger of launching something. So again, it's only when the 0 to 1 transition happens. So at this moment, I have a 1, 0. Please focus on this side of the screen on the left. So here I have a 1, 0 ready. The moment I press the trigger, it's going to send the output to a 1. Now, you see that? So now notice that the output Q, which is down here in pink, became a 1. If I now change this input to, let's say, try to reset to 0, let's change J to 0 and K to 1. Right? Again, the output is not affected yet. You can see that the inputs have been changed because I changed the switches, but the output is not going to change until I give it a 0 to 1 transition. So at this moment, I'm going to click the switch, and nothing happens because it was a 1 to 0 transition. I want it when it first turns on. So here, the moment I click the switch now the output happens. So again, let's emphasize the fact that the output is gonna change only when the clock goes from 0 to 1. So right there, I'm gonna let go of the trigger, and I am going to, let me put back a 1, 0. So this is what I'm loading at the input, so which a 1, 0, it's gonna set to Q to 1 when I press the trigger. So I'm gonna press the trigger now, and the output becomes a 1. Again, if I now load a 0, 1, let go of the trigger, nothing happens, press the trigger, the output becomes whatever is loaded at the input. Now, I've only mentioned so far the set and reset as loaded inputs. Let's talk about the 0, 0. So at this moment, my output Q is off. If I put a 0, 0, it's going to remember the previous state of Q. Oh, there's a missing Q letter right there. But anyway, so here you have 0, 0. When I let go of the trigger, nothing happens. When I press the trigger, it's gonna stay 0, okay? It's very different if I put a 1, 0, which is set. I let go of the trigger, press the trigger. Now my output is on. Now, if I go to 0, 0, it's going to remember that state. Let go of the trigger, press the trigger. Now it's remembering a 1. So as you can see here, the input 0, 0 remembers whatever it was. If Q was 1, like in this case, let go, press it, it remembers a 1. But if I reset it, press the trigger, and then I load a 0, and I let go of the trigger and press the trigger, now 0, 0 remembers that the Q was off. So what you have to realize is that for 0, 0, the output is going to remember the previous state of Q. If it happened to be 0, it's going to stay 0. If it was a 1, it's going to stay a 1. The last state that we should look at is the 1, 1. So 1, 1 is when both J and K are a 1, the output goes to the opposite of the current state. Here, the output is a 0. The Q output is a 0. Let go of the trigger, nothing happens. Press the trigger, it's going to toggle to a 1. If I let go of the trigger and press it one more time, leaving the 1, 1 at JK, it's going to toggle, but now it's going to toggle to the opposite of 1, which is a 0. So at this time, if I just keep pressing the clock or triggering the clock, it's going to be flip-flopping. It's going to be toggling. So let go of the trigger, press the trigger, toggles. Let go of the trigger, press the trigger, it toggles. Let go, press the trigger, toggles. Let go, press the trigger, toggles. So this is very in slow motion. In reality, when we use these kinds of flip-flops, I'm not using a clock in this manner to run the simulation. We use actually a clock source, 555 timer, some sort of on-off pulse instead. If we're breadboarding this, we would use like a function generator or something like that. So I am going to make this, my computer is maybe a little bit slow, so I'm gonna make it, actually, let me make it 20 hertz. I'm not sure how fast that's gonna be. And let me call this is my clock source. So this clock source, I'm gonna take this one out and I'm going to replace my clock input from there and see if that one works. So let's see how fast this one is blinking. I may have to slow it down. I'm not sure. Oh, it's a little bit fast. You see how it's on and off, on and off. Let me slow it down. Put 5 hertz. Usually it doesn't go that fast on my computer. So let's see. 0. There you go. Okay, so that's good. So it's blinking 5 times per second, according to my computer. So here you see the clock turning on and off, on and off. Because my JKs are set to 1, 1, the output is always toggling every time the clock trigger goes from 0 to 1. The 0 to 1 transition is called the rising edge or the positive edge of the clock. Notice if I were to look at my chart, now if you look at on the right-hand side, notice that the pink output Q down here toggles or changes state every single time my green clock goes from 0 to 1. So not now, that pressing the trigger, let go, press the trigger, let go, press it, let go, press it, let go, press it. As you can see here, the pink output Q, every other edge, the output toggles. So you can see here that it is always just toggling at half the frequency. Now here, let's talk about the overrides. That's the last part. If I activate the override set forces Q immediately. It doesn't wait for the clock or anything like that. Immediately, whenever the override set is activated, it's going to force the output Q to be on and stay on no matter what the input of the JK and clock is happening. So let me do that now. And you can see the moment I turned on my override set, which happens to be graphed here in the pink wire or dark magenta wire. Here, it's a 1 because I have the switch set to a 1, and my output Q, as you can see, it's forced to stay on, no matter what the clock is doing, no matter what J and K is doing. If I release that override, then the clock takes over again whenever the trigger is pressed, as you can see. If I activate the override reset down here at the bottom, the moment I activate the override reset, you can see here in a gray probe, then the output became low or 0 until the override reset is released. And then the output follows whatever is happening at the clock. Now I have it set to toggle, but it doesn't necessarily have to be set to toggle. For example, I could put 1 0 and the output is always, the overrides are not active. And I am forcing a 1 at the output because that's what 1 0 is going to be doing at JK. Now, if I override the set, you're going to see there's no difference because the output is already on and I'm forcing it to be on anyway. If I release it, it's going to just go back to following the clock. But it's still, so sometimes whenever J and K are forcing a set, overriding doesn't affect it. But the reset will affect it in this case. The moment I activate it, the output is going to go to 0, as you can see down here. And it's going to stay there until I release it. And the moment I release it, then the clock, whenever the clock triggers, then the output becomes 1. I want to point out, I'm going to pause here. I'm going to stop the simulation here. I want to point out here that when I stopped, as you can see here, I stopped resetting it. The output didn't go back to being a 1 immediately. It had to wait until the clock told it to. So the same, what I want to make sure you understand is that the override set only forces a 1 and the override reset only forces a 0. When they are deactivated, they don't force anything anymore. They just back off and the output then follows the clock. So as you can see here, when I stopped forcing the reset, my output didn't change immediately. It had to wait until the clock triggered again. So there you have it. Just to recap, the JK inputs are synchronous to the clock. The clock affects the output Q only on the trigger, which is in this case a 0 to 1 transition. The override set and reset are not synchronized with the clock. Those take over immediately as soon as they're activated. In this case, activated with a 1. The output inverse Q not or not Q is also available. And as you can imagine, it's always going to be the opposite of Q. Lastly, I want to say that sometimes you're going to see inverters or little circles or bubbles at some of the inputs. That just means that the logic is reversed. So for example, if there was an inverter on the set right here, a bubble, that means that a 0 will activate it and a 1 will not. So you would have to reverse your logic. All right, so that's a JK flip-flop. I hope that was helpful. That's all for now. Let's stop recording.